once again. This is the stick welder. It's an arc welder. This is a really old version. You got your different settings: AC, DC, negative, DC positive, and then your amperage. And on the side of it, there's a chart. It tells you, gives you an idea of what you want to put your settings at based on your electrode and your material you're welding. So, it just plugs in, 220 volt cord, and out the front, this is your grounding clamp, which you ground your material you're working on, and then this is your electrode holder. It's got a little trigger, little teeth, and you can stick it in there. You stick the bare end in the clamp there, and you can put it in multiple positions, whatever's easiest to weld with. I usually go like 90 degrees, and then you fire your machine up and you go welding. So the hood basically just blocks harmful UV radiation, and so you don't burn your retinas and all that stuff, and so you can see what you're doing. All right, so basically prep work. You gotta brush, get your material clean, as clean as you can, preferably. You get it nice and shiny, just like that, but I don't want to bring the angle grinder over and do all that. And you got your gloves, very important. It's hot, and long sleeve shirt. So basically, you take your two metals, or one, however, but taking two, and then you have to strike your arc. And usually when you're putting two pieces of metal together, you want to tack weld it. So that's just like a couple really small welds, so it's just in place and it's holded there. And then you can go back and lay your bead. So I'm just gonna tack it real quick. You should see this big arc, a lot of sparks. Things should be flying. Sometimes with the sticks, the filler metal inside the flux will be recessed back and it won't be able to make contact. So you just break it off, show bare metal. But yeah. See, it took a few times to get it to strike. Usually once it gets hot and it's going, it's a lot easier to maintain that. So that's tack welded. See that? And there'll be slag over the weld that you chip away. Real metal. So it's nice and sort of strong. Yeah, I don't know, does anyone want to, were you able to see? All right, well, you can get real close up here. Oh, you should be fine. So if y'all want to come and look at this, just laid a bead, and so I was talking about the flux. You can see how that was 90 degrees when it started, because I laid that weld in there, pulled it in when it cooled. But you see the weld see what it looks like now? Then you chip away your flux. A little brushing. That'll show you what your weld looks like. It's not a very good weld. As you can see, it's kind of just down on this, on the bottom. Yeah, it's not even really up on this piece. Yeah. It could be due to the electrode I'm using, or just my technique.
Is that the same one we passed around in there?
This is the exact same one. Yep.
So you don't think maybe our oils up our steam? Did it have anything to do with anything?
Potentially, I don't know. It's probably just my skill set. But you know, maybe.
Let's see, that's
These are the 6011s. This is what are typical, but I think I was trying to weld some of them earlier, and they just weren't doing much. You see, it'll say it's like stamped 6011. That was a little better, I think. Break the flux off. Usually with these 6011s, there'll be a nice thick coat of flux over when the weld solidifies. I'm pretty sure these are very moist. Because I've never welded with one and had these results. Yeah, it's not a very clean weld, but I do think it's pretty solid. So yeah, basically, I'll show you kind of my tech. How you kind of move the rod.
Stuff and then to put that on and then not be able to see what you're doing until
Yeah, sometimes it is.
This is auto darkening, so I can see until it sees a bright light, and then it goes dark. So it's a really good piece of equipment to have, especially if you're learning.
Yeah.
So you can see. Basically, you have to strike your arc, and it's kind of like striking a match. Like if you just stick it on there, it's just gonna melt to it, and it's gonna get stuck, and then you'll just have to, and then you want to rip it off quickly, or else it's just gonna ruin your electrode. But so you have to kind of like strike an arc, so like tap it and pull it away, like pretty quick, and keep that arc. And then once you have that arc, you kind of just like sweep back and forth as you lay that filler metal down into a bead. And I mean, that's kind of all there is to it. I mean, there's a lot more to it, but that's kind of all I can tell you about. Yeah.
All right, so this is the plasma cutter. I have my grounding clamp attached to the piece of metal that I'm working with, and so it already looks pretty crazy. That's just like heat and oxygen flowing through it. It's set at 70 psi, so that's what's coming out right here. And as you see, when it touches the metal, it's going to create the arc and create that circuit that we've been talking about. And well, I'll just go ahead and do it. I wouldn't look directly at it. That's why it's not as bad. It's not as bad as a welder, but it's still not great. So, don't look directly at it. And I'll try and do as straight a cut as I can, and you guys can come look at that. So that was pretty quick. I'm going to show you guys the piece that I cut. It's got like little ripples in it, but it's really smooth. You can see there's a little bit of that, I'm just going to call it slag for lack of a better word right there. And that's easily removed, as I said, with a hammer.
If you still have it close,
That's
when
incredible.
you get it going.
Yeah, and that's 1/4" steel, which, yeah. Granted, I did just put new tips on that thing, but it's
Sometimes you think car.
pretty amazing. And you can take
What were you using before you got the class now?
just angle grinders. Yeah. So yeah, if you have to make like a 3-foot cut out of 1/4" steel with an angle grinder, that's like 30 minutes. Whereas with the plasma cutter, it would probably take you like 30 seconds. It's pretty amazing. All right, and like you guys, we actually have a little piece of metal. We have a little project, something that we're gonna repair for Rocco, who's, you guys may know Rocco, he's a farmer here. This is part of his tractor. It's a little pin that holds his fork attachment on there for picking up pallets and whatnot. So we're gonna go through the prep work to get this prepared for Dan to weld it. All right, and it looks pretty bare, right? Like, kind of looks bare, but it's not really what you want. And this doesn't really lay flush on there, so it looks like I'm gonna have to grind out a little bit up here to clean it up so it can get right flush on there. So, great task for the angle grinder, the jack of all trades in the metal fabrication world. So for this, I'm gonna switch to the grinding wheel. The way an angle grinder works, so whatever disc you're using has a circle on it, and that gets seated around another circular piece that's on the angle grinder, and that keeps it seated in like perfectly centered position. This is a little nut that you place on there that keeps it from flying off. But this is something that's pretty important. You actually put it on there opposite between, on a different way for a cutting wheel as opposed to a grinding wheel. So there's a flat side, and then there's a side that has a little part that sticks up. And if you look down here, the cutting wheel is sitting flush with that circular piece that's holding it in the center. So you put this nut on the flat side on there, and then reverse for the cutting wheel. And since this is just a short job, I'm not going to use my respirator. But as I said, if you're going to be doing anything for an extended period of time, working with metal, it's a good idea to wear one. All right. Everyone all right? Okay, so I got this piece down to bare metal in a lot of spots, and again, this is gonna be seated like this. So I just gotta make sure where these angles are, there's bare metal. So right here, I'll probably want to get a little bit more on this side, a little bit more on this side. I beveled these edges too, so that there's a place for that welding bead to sit. but it looks like this depression might be a good job for the cup brush. But first, before I switch the grinding wheel off of the angle grinder, I'm gonna go ahead and get bare metal down on this piece. So I look at it and looks like I gotta grind a little bit away inside from the edges, and I'll probably do a little bevel around the edges too, so the bead can lay in around there the entire way around. You can use it with one hand if you feel comfortable doing that, so it leaves the other hand free. If you're just in like a quick little bare metal grinding, you can use one hand to hold whatever you're grinding and the other to hold the angle grinder itself. So I got that down to bare metal where it'll be contacting with the piece it's being welded to. And just to get all those little spots, and you can still even see on this one there's a little bit of rust left in there, a little crack, and that's something I can just hit with the cup brush and get that out. So I'll go ahead and switch that out on my angle grinder. Alright, I'm gonna hit this with the angle grinder, make sure everyone's got their ear protection in. A lot cleaner than it was before. So, where that little depression was, where there was rust in there, you can see it's pretty polished now. The angle grinder, or the cup brush does really well at making quick work of stripping rust and whatnot. So now I'll go ahead and do that for this piece as well. And something else, the cup brush, since it has those little like wires sticking out, it can bounce a lot. Like if you hit an edge or a corner, it'll hit it and bounce back at you. So you gotta be really, when you're really all the time when you're using an angle grinder, you like, especially at the beginning, you want to have both hands on it, a firm grasp, because like even if you're cutting or grinding, you can get caught in like you know, a wedge or something, and just if you're not careful, it'll fling right out of your hand. So for this one, since I'm using the cup brush, I'm going to put it in the vise.
It'll put this little light on the other knee. It's not going to underneath tonight. If I run it for 10 minutes,
so yeah, you can see.
yeah. Oh, yeah.
A lot prettier than it was before. Got that polished look that the cup brush was creating. There's still a little bit of rust in that divot, but for something like this, I mean, all this other material is going to get welded solid. It's not going to go anywhere. So, and he's going to have to weld it pretty hot because this is a solid piece, so it'll probably tear right through that.
I got my 2 little pieces.
All right. Well, let me just do a quick demo of cutting that same piece of metal with the cutting wheel as opposed to the plasma cutter.
You can have about maybe a 1/4 inch or 1/8 inch sticking out. Right? That's kind of important.
Okay.
It's got a bit of. That might be right. Oh.
And another thing with the cutting wheel and grinding, you want to avoid having the sparks like hit you directly, especially if you're wearing like organic fabrics, because it can catch them on fire and burn a hole in your clothes. So typically, if you can, when I'm cutting, I like to hold it like so, and since this wheel is turning this way, it's going to be shooting the sparks that way. And if this does get out of my hands, it's gonna fly in front of me, as opposed to if I was cutting like this and I lost a hold of it, it could shoot right down into my leg or something like that. So when you're cutting with the grinding wheel, you want the cutting wheel to be on the left side of the grinder, like so. So I'll just go ahead and cut entirely through this, and we'll see how much longer it took than the plasma cut. So not too much longer. It didn't really seem like that time, but the more and more you cut with your cutting wheel, the smaller diameter it gets. Therefore, the slower it makes the cut. And then you're wasting all these cutting wheels. Whereas a plasma cutter, you're still blasting right through.
How much life do you get out of the cutting wheel?
It depends on how you cut and what thickness you're cutting. And how much like fabrication you're doing. Like I have a cutting wheel at home that I've never had to change because I don't really do much work there. But I mean, like I was saying, if I had to cut like a 3-foot length of a 1/4 inch, that would probably take about 3/4 of the life out of a cutting wheel. And this cutting wheel I'm using is also, it's rated for stainless cutting, so it's a little bit beefier than just your regular mild steel. And we pretty much get these all the time just because they are more durable and last longer.
How much does a wheel like that cost?
You usually get them in like packs of 3 for a few bucks or so. Sometimes you can find them at Tractor Supply for like in a pack. So yeah, for prepping, really you want to get it clean. You want to get a bevel in it so you have a place for your bead to lay. And you also, after you've cut something, you want to knock off the chamfer or a burr from the plasma cutter so it's not getting in your way or possibly cutting you. Those burrs are pretty sharp.
Yeah. I mean, I can't say that's not doing it.
Go ahead and send this over to Dan.
I'm going to use my fancy auto darkening hood that I got for like 30 bucks, by the way, at Harbor Freight. Yeah. So they're pretty cheap. Same place we got this guy for $90, which is a steal, man. I'm telling you, buy one of these and at least like dink around for a little bit. You're not going to build the Eiffel Tower or even like your like front gate with it, but I should have brought in some stuff. When I started, I made like arts and crafts stuff, lamps and pictures and mirrors, a lot of frames, that kind of thing. And this thing did it all. Just gonna stress that. He's actually prepping something that I'm gonna weld, but I'll just find 2 random pieces and I'll show you this guy in action at least. Let's see. I should have Johnny prep that for me. But you see, I got bare steel right there from an old project, whatever this was from. Okay, got that. Plug this guy in.
You also always want to pay attention.
Turn it on. These things have a little fan that runs in them that keeps them cool.
It does break loose.
One thing we didn't talk about was duty cycle. Is that something anybody's familiar with? Duty cycle in layman's terms, is like, think of it as just like an on-off pulse. It's the amount of time that you can be on compared to the amount of time that you can be off. If you say if something has a 20% duty cycle, it means you're going to run it for 2 minutes and leave it off for 8 minutes. This thing has like a 0.01% duty cycle. Or so, I mean, I'm exaggerating, but it just means that this thing overheats really easily, right? Okay, that's just because it's not very robust, right? It'll put this little light on when it overheats. It's not going to overheat tonight, but if I run it for 10 minutes, it might. That is something, if you're going to buy a welder, that's something really to pay attention to. The duty cycle is kind of a general rule of thumb. Higher the duty cycle, probably the better the welder, and you can pay for it too. Okay, so here I am. I got my 2 little pieces of 1/8 inch that I'm going to try to just weld together. I got it on high heat because I know I need high heat. I'm going to go ahead and open this up, and I'm just going to check my little chart. Okay, I want to weld 1/8 inch. Okay, max amperage and wire speed 8. So let's set my wire speed up to 8, and let's see if that works for me. Watch this. When I press this button, that's pretty fast. Like, that's really fast. I don't know if I'm comfortable with 8, but we'll try. These are called MIG pliers. I mean, anything will do. Wire snips will do, but MIG pliers are really nice. It's kind of like the all-in-one tool. Keep it close by. You want to have about maybe a 1/4 inch or an 1/8 inch sticking out to start. Nice. Ground it. Sometimes it's finicky, man, and you might need to actually get down to bare metal on your ground. Most of the time, not really an issue. I actually found that was a problem with the plasma cutter last time I used it. All right, here we go. So I'm going to take my little electrode, and I'm going to point it up. This is a really awkward angle for me, but I'm going to do it anyway. And I'm going to try to actually maintain a small gap in between this wire and the piece that I'm working on. Small gap meaning another 1/8 inch or something like that. You'll find that all my gloves, because I'm like the kind of person that learns how to do it one way and then I just kind of never improve on it. All my gloves are all burnt on the left hand because I'm going to steady myself with my left hand. I know you can go to some like welding shops and they'll sell you left hand only gloves, so I know I'm not the only person that does it. Again, I'm going to be right here. I'm going to maintain that 1/8 inch gap. Here we go. And that's ugly as it gets. I think that my wire speed is probably a little fast. You see how it's hopping around a little bit. Every time, you're just going to kind of play with it. You're going to have to just get it on your own. So you look, if I'm actually going to try to weld on top of that, I probably want to go grab a brush, and I'm just going to kind of scrape off that flux. I'm just using a cut brush. You get a really nice finish sometimes if you can do it really quick. If you can grab it when it's still hot and then cut brush it, it'll actually kind of smooth out pretty nice. I know a lot of the blacksmiths will do that. They as soon as when they're working something in the coals, they'll pull it off, it'll develop that scale right away, and then they'll brush it real fast and it gets a really nice finish if you can grab it when it's still hot. All right, I'm going to try this again with my lower speed. So that sounded a little nicer. It's a little more consistent. This is kind of a bad example, but normally if you're going to be, who's going to weld 2 pieces together like that? But, you're going to be taking it in most applications and you're going to be kind of dragging it across what you're welding. Say I wanted to weld these 2 plates together. Of course, I'm going to make sure it's not going to bend and change shape and everything. But I'm going to start right here at the top, and I'm going to drag it down, maintaining pressing that button the whole time, maintaining my 1/8 inch or 3/16 or whatever gap. And, I've heard it 2 different ways. Some people say to just maintain a steady, straight line. Some people do this. There's a couple of different ways, patterns, and it might be worth maybe even drawing a picture or something of this. But imagine this shape. Just making circles, and I'm going down the line. That's why every time most welds you see look like something stacked on top of something else, right? And when you get in the mask and you look at it up close what you're seeing, that's called the bead. And what you're seeing is you're actually heating the parent metal on both sides, and then you're adding metal, and what you get is a little puddle of molten metal. That's what people take, they do that drag thing, is because you can't really get it until you see it and do it in your own hands. But you're taking that puddle and you're actually pulling it. And it cools as you leave it, but you always want to keep a little hot puddle going. And you'll just know it with practice. You'll know when you get the puddle. You'll hear it. It won't be like that just was. It'll be a steady like hum. You'll get it, and then you'll feel it, and you'll know when you lose it. And then a lot of times you just maybe need to start over. Cool it off. I mean, you don't have to let it cool all the way, but stop, clean it, start over. Every time, you know, I might get the puddle for 8 inches, and then I'll lose it or something. Maybe my nerves get to me, or a lot of times it'll get so hot that it'll burn through what I'm welding. You'll start to get little holes. That happens a lot when you're doing like 1/8 inch type stuff with this kind of things that we do here. So you guys kind of see this thing works. Like I have no doubt that's welded. You know, I'm sure it is. I might be able to break it if I really want to. But you'll see this thing is like a Cadillac, and this is the, you know, your bicycle, I guess. So we're gonna put that up. And Johnny prepared this. I don't know if you guys caught this, but Johnny actually prepared this little pin that we're gonna build for Rocco's tractor. He had a little piece break off of his bucket pin. So he's prepared both sides. You got good, clean, bare metal. So I'm gonna put this back in my vise. And our MIG welder, just listen to it. It's like purring, you know. The gas, the argon gas that I was talking about back here, we get this filled. I can't remember how much it was. Evan just got it filled last week. I think it's $80 or something like that. It's less than 100 though. It's expensive, and when you're doing it like a lot, you're gonna go through it. But on the other hand, the wire is a little bit cheaper. Like, honestly, I can't remember. I think this 10-pound spool is around $30 versus 75 or 80 of the flux core. That tends to, you know, it lasts a long time. We do a lot of welding here, so it's kind of hard to get a sense of, if we were just doing it around the house, how far this stuff would go. Again, here's our big chart that I was talking about. Big spool, that's the feed mechanism. Gas comes in through the back. And here's our big gun. Spool gun is that same conduit that I was talking about. It has the wire that feeds through it. Look how that runs a little bit slower than the other one. That's a much different material, because you see it's a lot harder for me to snap it off. You know, you can tell it's not hollow. I can bend it all around and, you know, all that. A lot of times when I'm working with the flux core welder, I might maybe leave it on for a second. I'll just snap it off with my fingers, but this one, you pretty much always need to have your little pliers around. Again, I snipped it about 1/8 of an inch right there. With your gas, I need to turn it on. Okay, we keep that, you know, around 25 or 30. I was telling one guy, if it's like a little bit windy, sometimes you can cheat and turn it up a little bit. You should be able to hear the gas come out of this nozzle. There's a little tiny tube in here too that delivers the gas. You should be able to hear that gas come out of that nozzle when you're welding. Sometimes it'll clog up. If you get a lot of splatter, it'll clog up the inside of that nozzle. Like you can see a little bit of buildup on the inside there. Can you see that? Probably bad light, I bet. That's the spatter that we're talking about. All right, so I just kind of took the whole thing off. These things have a few parts that every now and then you need to replace. These guys, we got an extra shield if you ever need it. We also got little tips. You might see these sitting on the rack if you guys go to the store and you look at welders. These things, you know, I tend to run through these pretty quick. Other people that are better than me make them last a little bit longer. What happens is they'll just maybe short like arc actually inside the tip, I think is what's really happening. And they just, there's too much friction inside of there. And they're kind of like a perfect ream, so it's really hard to, you know, if you're tricky, I guess you can hollow them out and reuse them, but I don't ever have much luck with that. So, again, we got our ground clamp, because we got to make a circuit. We got this piece that Johnny prepared for us. It's clean on the back side here. I'm gonna lay it right like that. And you see how he's got a little bevel cut? Like a little notch? What I'm gonna try to do is fill in that notch. I need to set my settings on my welder first. Just as a rule of thumb, you know, this welder has markings on the dial itself that tell you what size you wanna go with. This is a little heavier piece of steel, you know, it's a tractor, it's an implement, you know, it's gonna see some damage, I guess. All right, so I've turned up my voltage a little bit, and I'm just gonna turn up my wire speed. They generally stay around the same. I'm probably gonna have to adjust it a little bit, get it dialed in right. I'm kind of more or less right down the middle here on what this thing's capable of. I'm gonna do that. You'll see I'm actually gonna tack it, tack it, tack it, and tack it, and then I'm ready to weld it. Again, if I just go like, you know, all out and weld it right here, it's some kind of tendency to pull away and it's gonna change shape. I'm gonna try to keep this thing as perpendicular as I can. Again, we're grounded down here if you guys can't see that clamp. Okay, that sounds a little fast. I'm actually gonna turn my speed down just a little bit. It was hopping around a little bit too much for me. Okay, I got a good pull on that one. You guys can see that. That's just called a little tack weld right there. So that's just gonna hold it in place. Right, that's the difference. You guys see how that's resting up above the weld? I know I didn't get a penetration in there. When it's bouncing like that, no way. I mean, you're still depositing material, but it's not welding. I'm just gonna, you know, if you do that for too long, you're just gonna end up grinding it off. You wanna penetrate, and you kinda, you know, you'll know when you get it. Set that back up. What I'm gonna do is tack it here, and I'm gonna go back over here to this opposite corner, and I'm gonna start my bead. Okay, you guys see that? You can see I was doing a little clamshell pattern there, and you can kind of see it as it cools off. See, it doesn't look too much like a clamshell, and I think that's a good thing. You know, I'm pulling that at a proper speed, that it's not pulling up and then diving in and pulling up. That, you know, you can make really pretty looking welds that way too. But usually I get that kind of look when I think my heat is maybe a little bit too high. I get these peaks and valleys. What I got there is basically a straight level line. No doubt that is has more to do with Johnny's prep work than it does to do with my skill pressing that button. So we got a little carbon buildup here. I'm gonna scrape that off with my cut brush. Just try to get it clean, and I'm gonna run this. Again, I'm gonna pull on this. I always have better luck pulling. All done. You guys see all those fumes? Yeah. Hold your breath. So that's the weld. Should go ahead and brush it, while we got it. I'm going to show you something interesting here. You see this little burn mark down there? Right here is where we had my grounding clamp hooked to it. I mean, you got to remember, it's just a circuit from here to here. It's actually generating quite a bit of heat where it contacts right there. Just know that if you're like working on something huge and you're laying across it, especially if these wires start to get frayed or you don't have a good connection here, you still got to pull that current through effectively a smaller wire if you're not making good contact here. That's it. I think if anybody has any questions, I know it got real late. Appreciate y'all sticking around. Just gonna let that cool off on its own. I'm not gonna go try to quench that or anything. Probably not hot enough to make a difference, but better safe than sorry. Okay, so you guys saw cutting methods, hopefully. That's half of it. I know these tools kind of add up pretty quick. You don't need all of that. If you're gonna get started welding, I'll tell you what I had was an angle grinder. I still like to use an old-fashioned grinding wheel because it's what I learned on. So it's cheap. You can get started for pretty cheap if all you're gonna do is get started. $90, I would say, I'm gonna backtrack. I don't really recommend the $90 one. Maybe get the one that's $150 or something. You'll appreciate it. A lot of times if you're buying one of these, they know you're just starting out, so they'll give you one of these too. And the angle grinder, that's really what you need to get started. Somebody here had an old set of torches, look at Grandpa's shed. Go to these old not antique, but the barn sales, Craigslist. I'm sure a lot of this antiquated equipment is probably going all the time. I mean, these oxyacetylene torches, I don't think they've changed in 50 years probably. I mean, I can only attest to 10 years, but I think they're pretty much the same thing. Same goes with the stick welders are pretty much the same thing they've been using. This obviously is the easy route. Like I said, I think this one is on the shelf. This is probably the little bit nicer. It might be about $1,000. I think if you start stepping down, they've got the Miller 140 that I'm not sure. I think it's around 600. I think I saw that at Tractor Supply for 600. Any questions?